Alright, so in this video we're going to start to learn about how to do mole-to-mole conversions. So we ended the last video with looking at balanced chemical equations. Actually, this is the equation that we looked at. And we learned that they are a recipe that just shows the ratio of things in moles. And so we can write molar ratios, and we said that those were actually conversion factors. So now we're going to use our balanced chemical equation and our molar ratios to figure out relative quantities of things. So the first example we're going to do, it says if there's 3.34 moles of aluminum oxide and they decompose, how many moles of oxygen are going to be made? So we always start our unit analysis problems by writing the value that we're given. So we're given 3.34 moles of aluminum oxide. And I want to go from moles of aluminum oxide to moles of oxygen. So my two items that I'm going to be using here from the chemical equation are here and here. So we want the moles of aluminum oxide to cancel, so that will have to go on the bottom. So I will say 2 moles of aluminum oxide decompose, and when they do, for every 2 moles that decompose, I actually make 3 moles of oxygen. So I put the 3 moles of oxygen on top, and that cancels, and so we just take 3.34 times 3 divided by 2, and that gives me 5.01 moles of oxygen. 5.01 moles of O2. All right, let's do a couple more examples, and then I think you'll have enough in order to do the worksheet. So let's say that we have a combustion reaction where we have C2H2 plus 5O2 gives us 4 carbon dioxide and 2 water. So this is our balanced chemical equation. So it's always important that we have the accurate balanced chemical equations in order to do these conversions. So let's say that we react 3.84 moles of C2H2. How many moles of oxygen are needed in order for this reaction to go? So up here we did a conversion that went between a reactant to how much product was formed. In this case, we're actually doing a reaction to figure out if I react a certain amount of product, how much of the other product do I need? That is actually called the stoichiometric amount, or the exact amount that you would need so they completely react and turn into products. So let's say we said 3.84 moles of C2H2, and I want to go from moles of C2H2 to moles of oxygen. So the moles of oxygen need to go on top, and the moles of C2H2 go on the bottom. So this will cancel, and we are left with 3.84 times 5 divided by 2, and I get 9.6 moles of oxygen. So that would be the stoichiometric amount, the exact amount of each reactant that need to be reacted so that everything is converted and changed over to products. All right, let's do one more. So in this case, I'm going to go again between a reactant and product, but I'm going to go the other way this time. So let's say I have 8.95 moles of water, and I want to figure out, well, how many moles of this C2H2 would I need in order to make that much water? So on the bottom, I'm going to have my moles of water because I actually want that to cancel, so I just put 2 moles of water. And then on top, I would put 2 moles of C2H2. So the 2 to 2, I would end up with 8.95 times 2 divided by 2, so I would end up with 8.95 moles of C2H2. Okay? So all of these problems are exactly the same. We just need to have our balanced chemical equation, start with what we are given in moles, use a conversion factor, making sure what we're trying to convert to goes on top, and then we can solve for a different amount. It does not matter if we're going reactant to reactant, or reactant to product, or product to product. They are all exactly the same.